Hello everybody, thanks for joining today's session. My name is Adrian and today I'm gonna talk a bit about developing single page applications with Webiny. And Webiny basically enables you to create all kinds of single page applications from simple admin interfaces to something more complex, single page applications facing, public traffic, like public websites basically. And before we dive into that a bit deeper, I wanted to take a few slides and talk a bit about single page applications. So what are single page applications? What do they represent? Well, I'm sure if you are a developer, you've probably heard about this term, but yeah, let's quickly summarize its main points. So number one thing that characterizes single page applications is, of course, the client-side rendering. So basically what that means, it means that the backend doesn't generate any HTML. So every HTML generation that's happening, it's happening in the actual browser. And a cool thing about that is that while you're navigating your app, there are basically no page refreshes, like you would see in a traditional website. Another cool thing about single page applications is that we have a bit cleaner code. So traditionally we would, generate HTML on the backend with probably with some database calls, a couple of if statements, and altogether that would pretty much become a mess very soon. And with with single page applications, we don't have that. We have a clear separation, so we have front end and backend. And backend in that case is basically just providing the data via a API. And finally, single page applications are easily served, especially if we are talking about serverless approaches. So the only thing that's really needed is to have a static file storage. In our example, in our case, we might use S3. And if we put a CloudFront in front of that, we can make our site load super fast. And the only note I would like to point out there is that when I say super fast, the single page application assets are served fast, but it all depends on your API. If your API is slow, then unfortunately your single page application will be slow as well. So single page applications are cool, but they have one small disadvantage. And that disadvantage will be shown in these following slides. So imagine you have a simple website that's built with a single page application approach, and you wanted to share a link to a friend on a social network, for example on Facebook. And when you share the link, you would expect to have a link preview that Facebook automatically generates, something like we see now. But if you didn't work with single page applications before, you might actually see something like this. There is no preview, and there is no page title and things like that. So what is the problem? Well, the problem is that single page applications always serve the same HTML. If you remember, we mentioned that single page applications generate HTML, in other words, the user interface, in the actual browser. So nothing is being rendered on the backend. And that's the problem here, because when Facebook requests your website, it won't wait for the JavaScript to load in the actual browser. It will just rely on the initial HTML that was served to it. And as we can see here, the initial HTML is always the same. It's just basically a generic HTML containing a simple title and a couple of links to other assets. So this is basically the reason why Facebook cannot generate a link preview for us. But this is only one part of the story. The more serious problem that this poses is lack of search engine optimization support. And even though search engines are working towards a better support for single page applications, to this date it's still not on a level where we could confidently say we can completely rely on the single page applications and have a decent search engine optimization support. So what do you do? Well, the first concepts you will stumble upon while researching this topic is client-side rendering and server-side rendering. So we already talked about client-side rendering. We basically said it's rendering of HTML, or in other words, user interface, completely in user's browser. With that, we now have also server-side rendering, and as the name itself says, it includes rendering HTML on the server side. And what that does is basically resolves the problem that we've just encountered, because now the server is not sending the generic HTML we've seen to the client, but it actually includes some meaningful HTML, an HTML that all other web crawlers can actually look at and generate some content with it, and probably search engines are going to update their indexes. And there are a couple of ways to do this. It all depends on what are your needs and requirements for the project. And to help us decide which approach is the best, we can take a look at this summary. It's basically brought up from a document hosted on developers.google.com, and it shows us all of the available rendering techniques, or should I say approaches, that we can use on the web. We can see there are 5 of them, and we're not going to go too deep into every approach. We're just going to give a high-level overview of what's out there. So beginning from the right side, we have full client-side rendering. And this is basically what we've already encountered. So we are always serving a generic HTML to every user, and the whole UI generation is happening in user's browser. This is for a lot of cases a great approach, but have in mind that if search engine optimization is a concern, this approach won't be a good choice for you. And but note that this approach is also always good if you are building some kind of administration interfaces or protected areas. Basically, areas of your applications that are not exposed to search engines or any kind of web crawlers. Continuing on with the next approach, we have client-side rendering with pre-rendering. Well, if you ever used Gatsby before, you might be familiar with this approach. So we are actually building our website like any other single page application. The only difference is in the build process. So in here, when we execute the build process, we are actually building all of our pages in advance. So what that does, it generates a bunch of pages that we can actually statically host on, for example, S3 bucket, or maybe some of the other popular choices like Netlify or Vercel. And being statically served, that enables us to have a pretty fast website. The only downside of this approach, since the pages are built in advance, we cannot have a lot of dynamic content in here. Basically, every time a content changes on a page, we actually need to rebuild the whole website. And if your site is dynamic in content, then probably this approach won't work for you. In the middle, we have server-side rendering with rehydration. Now, this is an interesting choice, definitely. And basically, what it allows us is to have a mix of a single-page application and HTML rendered on some sort of backend. When I say backend, I'm not targeting any specific resource. I'm not saying servers or Lambda functions or anything. It doesn't matter at this point. The point is that the backend is generating HTML for us, and when the user actually visits your website, he will receive it. And what's cool about this approach is that the JavaScript will know how to connect with the initial content that was served, and basically the user continues using the website as a regular single-page application. And this is great because it enables search engine optimization support, and gives a great user experience for the user. Finally, the two approaches on the left, we have server rendering and static server-side rendering. These might not be super interesting to us, but I should mention that in some cases these approaches are still a valid choice. So for server rendering, this is something that isn't a single page application type. It's actually relying on HTML generation completely on the backend. So that means, in other words, that when you click on a link on your website, a full page refresh is happening, and you lose that nice user experience that single page applications provide. And on the right side of that, we have static server-side rendering. It's similar to rendering to the build process we have with Gatsby, although in this approach we are completely removing the JavaScript. So you end up with really static pages. And yeah, for some cases that's actually also a good approach. As we can see, Docosaurus and Netflix are mentioned here. So the question is which approach to choose. As mentioned, it really depends on the specific requirements that you have in front of you. And this is something we had to analyze while we were building Webiny ourselves. We wanted to make sure that the approach we choose is the right one. I'm not going into details what actually we've tried along the way, but if you are interested in that, you can certainly give this article a look. It's called Serverless Side Rendering, the Ultimate Guide. And it was posted on our blog a while ago, but it basically goes through all of the approaches we've tried, all of the advantages and disadvantages, and so on. Right now, I will just show you which approaches we use in every Webiny project and how we made it work. We will take a look at the cloud architecture, how it's organized, and we're also going to take a look at the actual code. So with each Webiny installation, you end up with two single-page applications. We have the admin app and the side app. And if we take a look at the actual project, you can see that in the project root, in the apps folder, we have two folders, admin and site. And as you might guess, the admin folder represents the admin site, and the site folder represents the actual public website. And just to be super clear on this is the admin interface that you automatically get with each Webiny setup. And this is a simple page that you also automatically get when you first install Webiny. It's basically a simple welcome to Webiny page. So when you think about it, we have requirements in front of us. We have the admin interface, which doesn't need to have the search engine optimization. It can be a simple, fully client-side rendered app. And for the public website, that's of course not possible. We're gonna need search engine optimization here. And as we've already mentioned, the full client-side rendered single-page applications won't help us there. We're gonna have to pick another approach to be able to handle that. And if we return back to this summary of rendering on the web approaches, we can see we selected two approaches. So for the admin site, we've selected full client-side rendering, which you might have already guessed. And for the public website, we've chosen server-side rendering with rehydration. And that's basically because the HTML that needs to be returned to the user is not static. We have a couple of apps on the admin side that the users can use, and one of these apps is the page builder app, and it lets users to create pages dynamically. So there is no build process involved here. The page has to be available on the public website as soon the user presses the save button and publish, of course. So actually the server-side rendering with rehydration was our only choice when it comes to choosing the right approach for the public-facing website. So let's take a look on the cloud architecture level, what we needed to use in order to make these single page application types work. On the admin app side, we can see a rather simple diagram that's showing us two different resources that we needed to get the job done. First, we have this purple CloudFront icon, and it's basically used to to cache the assets that are being served from this S3 bucket here. And yeah, that's basically all there is to it. So all of the single page application assets and the code is located on the S3 bucket, and it's being served over CloudFront back to the actual user. So if we were to summarize this approach, we could say that for the admin app, we are using a simple full client-side rendering single-page application, which is the simplest type of all SPAs. And this approach is definitely performant because there is no processing, there is no backend processing. We are simply just serving assets to the user. And having a cache in front of the app actually makes things a lot faster. And finally, we've also seen, in order to accomplish this, we have a very simple architecture consisting just of two resources, and it all works. The situation on the other side, when we are talking about side app, is a bit different, and in this case we needed to introduce a couple of additional resources. And the first thing you might notice if you open your AWS console and if you navigate to the functions section, you might see that we have two additional Lambda functions deployed for you. They are called Webiny Site and Site SSR. So yeah, these two functions are actually responsible for generating the HTML on the server side. And if we take a look at this architecture, we can immediately see that it's a bit more complicated, but I will walk you through, and I'm sure you will understand how it works. So from the left side, of course, we have the client request. It's picked up by the CloudFront, and there is two paths that can be taken from there. It all depends on the request that has been initiated by the client. If the client is requesting a simple asset like JavaScript, images, or CSS, the request is immediately forwarded to the S3 bucket. Pretty much is the same thing we've seen in the previous approach with the admin app. But this time there is a slight difference when it comes to serving the actual HTML. In case, for example, the user types our domain.com/about us. In this case, we are not responding with an asset like image. We are actually responding with the HTML. And in that case, the request is forwarded to the API gateway, which is represented by the letter B. And the API gateway is actually invoking this Lambda function that's in the center here, and which actually is responsible for returning the HTML. How does it do it? Well, first of all, let's explain one thing. In order to have server-side rendering, you actually need to have two different builds of your single page application. One build will be executed in the client's browser, and the other one will be executed in the actual server-side rendering environment. Why is this so? Well, simply because browser and Node.js environments are different environments, and different rules apply, and it's not possible that a single code can work on both of these. So that being out of the way, this server-side rendering build is executed on the Lambda represented by the letter D. And why is this so? Well, simply because the Lambda that's generating the HTML needs to have a lot of system resources, since the SSR is a very CPU intensive process. And yeah, that might be surprising, definitely, but it's definitely something that's out there and you need to be aware of. So that's why we have this another lambda, d lambda. And a cool thing here is that every time this lambda returns an HTML to the lambda with the letter C, we will cache this HTML into a real database. In our case, this is represented with the letter E. So next time the user actually requests the same page, the lambda with the letter C will just check the database if we have a cache already ready to be returned. If so, then we will return it. If not, we will invoke the bottom lambda function, wait for the HTML to arrive, store it into the database, and finally return it back to the client. And one additional scenario that can happen here is that the client might request a page that's already in the database, cached, but the cache might be outdated. And in that case, the lambda with the letter D needs to still be invoked in order to get the fresh HTML. In general, caching and cache invalidation is a complex topic, and there are different ways you can do both of these. But this approach we currently have here is something we've settled with for the moment. It works well, especially if the page is cached on the CDN. And if that's the case, users get their HTML in less than 100 milliseconds, which is super fast. So these are some of the main points of the site application and how we render that. So we are using server-side rendering with the rehydration. It's a bit more complex setup and architecture than we had with the admin app. But the cool thing is that search engine optimization works this way because the HTML is generated always on the backend and sent to the browser. And to make it super fast, we've enabled some caching, and this way the users are receiving their pages really fast. And of course, this all doesn't require any special configuration. It all comes out of the box pretty much 100% ready. And yeah, this basically makes it super easy for the user to create powerful websites and admin interfaces. And we've reached the end of this session. I hope I managed to transfer some of the knowledge and that you learned something today. So thank you and see you in another video. Bye.